Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening.
Good evening, ma'am.
Good evening, children. Good evening. So see here. Yeah. So students who have completed the assignment which I had given, for the last class. First, I received from, first I received from Netra. Sindhu and Sanjay had sent it half complete, almost half complete, but not fully completed. Then I received from Danya. Netra, Danya, then Krishmika Shri. That's it. That's it. Anybody else? Have I missed anyone's name? I've received from Netra, Krishmika Shri, and Danya. Yeah, that's all. Madhumita had texted me as I had requested on WhatsApp. So I received the message from her mom. The others did not. Srijana, it was not by his parents, but he himself had texted that he was unable to submit it. But the others have not responded. The others have not responded. I did not get any message. See, that you were supposed to have your class that day. So you cannot have excuses for not completing it. You were supposed to have the class that day. So maybe it was too much for you to complete in 1.5 hours. So another half an hour extra, you could have completed it. It was not more than that. But okay, whatever you could complete in 1.5 hours, at least that you could have sent pictures. But no. So when there is no class and, when we don't connect on Teams and when some assignment is given to you, you take it as a holiday. No class today. But there was work to be done. So we are in 9th standard children. Please be responsible. When somebody is planning something for you, execute it. Execute the plan.
Ma'am?
Yeah.
Ma'am, I completed 9 sums, ma'am. I'll complete it today and send it to you on WhatsApp, ma'am.
Yeah. Okay. All right, children. So now we are going to discuss the answers or the proofs to the questions which I shared in the last class. So this is the first one. So here we have to prove that vertically opposite angles are equal. When are vertically opposite angles formed? When two lines intersect. When two lines intersect each other, then vertically opposite angles are formed. And we know that vertically opposite angles are equal. We have to prove the statement. We have to prove that vertically opposite angles are equal. And when are vertically opposite angles formed? When two lines intersect. When we say lines, they are straight lines. Lines means straight lines. So when two lines intersect, vertically opposite angles are formed. Okay, so here we have two lines PQ and RS. Or we have two lines PQ and RS. They intersect at O. Look at the figure. PQ and RS, they intersect at O. Okay. Now, what should we prove? We should prove which are the pairs of, we have two pairs of vertically opposite angles, angle 3 and angle 4, angle 1 and angle 2. These are the two pairs of vertically opposite angles. You know how to name angles, so I'm not reading this for you. So angle 1 is equal to angle 2. We need to prove that 1 and 2 are vertically opposite angles. So we need to prove that 1 is equal to 2. 3 and 4 form a pair of vertically opposite angles. We need to prove that they are equal. We need to prove that 1 is equal to 2 and 3 is equal to 4. That is, these two angles and these two angles are equal. Now, we can write 4 results using this, figure. We can write 4 results using linear pair axiom. You can write 4 results using linear pair axiom. Write any 3 of these 4 results. Write any 3 of these 4 results. Now, let me tell you the 4 results. Now, on the line PQ, on the line PQ, on the line PQ, you can see the ray OS, and below you can see the ray OR. On the line PQ, you can see the ray OS here and the ray OR below here like this. So this is the ray, this is the line PQ. See it, children. This is the line PQ. Can you all see that line PQ? Don't see this part. Can you see the ray OS on the line PQ? Can you see the ray OS on the line PQ? Say yes or no.
Yes.
Yeah, so we have a line PQ and we have a ray OS on the line PQ. So by linear pair axiom, angle 1 plus 3 is equal to 180. Because PQ is a straight line, so the sum of the angles on it will be equal to 180. And here there are 2 angles. So linear pair axiom, the sum of the 2 angles is equal to 180. Similarly, now don't see the proof, children. I'll tell you the other one. Don't see the proof. Now see, in the same way, PQ is a line. Don't see this ray now. Can you see the ray OR? Can you see the ray OR on the same line PQ? On the same line PQ, can you see the ray OR?
Yes, ma'am.
So what is the result? Yeah, so what is the result? Angle?
Angle 4 plus angle 2 is equal to 180 degrees.
Angle 2 plus 4 is equal to 180. Angle 2 plus 4 is equal to 180. And what did we get from the earlier one? 1 plus 3 is equal to 180. From the earlier one, 1 plus 3 is equal to 180. Now, this is about line PQ and the rays on it. This is about the line PQ and the 2 rays on it. Now, let's take the other line RS. Let's take the other line RS. Now, again on RS, you can see the ray OP on the line RS. Ray OP stands on the line RS. Don't see this part of the figure. Don't see this one. Ray OP stands on the line RS. So what's the result you have? Angle 1 plus angle 4 is equal to 180. In the same way, don't see this part of the figure. Don't see this part of the figure. RS is a line and OQ is a ray on it. So we have 3 plus 2 is equal to 180. 3 plus 2 is equal to 180. So these are the 4 results you can write using linear pair axiom. Write any 3 of these. Write any three of these results. That's what I was telling you. I'll tell you again, once again, just in case some of you have not understood. PQ is a line. Now don't see this side of the figure. Don't see anything here on this side. Okay, don't see anything. So PQ is a line and OS stands on it. OS is a ray on the line PQ. So we have the information angle 1 plus 3 is equal to 180 linear pair axiom. 1 plus 3 is equal to 180 linear pair axiom. Now on the same line PQ, don't see this part. Don't see this part of the figure. Don't see this part of the figure. On the same line PQ, we have a ray OR. Ray OR. So that gives us 2 plus 4 is equal to 180 linear pair axiom. 2 plus 4 is equal to 180. Now we are done with the line PQ. We are done with the line PQ. Now let's take the other line RS. Let's take the other line RS. Now, don't see this part of the figure. We have ray OP on the line RS. Ray OP stands on the line RS. So angle 1 plus 4 or 4 plus 1, whatever. Angle 1 plus 4 is equal to 180. And for the same line RS, Don't see this part of the figure. Okay, don't see this one. On the same line RS, we have the ray OQ on it. Or we have the ray OQ on it. So linear pair axiom 2 plus 3 is equal to 180. 2 plus 3 is equal to 180. Now, children, write any three. So you can write these four results. Write any three. And that's what I've written here. That's what I've written here. I've written any three. Okay. Now, how do you describe it? This ray stands on this line. This ray stands on this line. This ray stands on this line. That's how you present the answer. So we have these results. 1 plus 3 is 180. 2 plus 3 is 180. 2 plus 4 is 180. Right now, compare. After writing them, compare the results. Compare A and B. From A and B. From A and B. Call them. See the results. Call them A, B, C. Or you can call them 1, 2, 3, whatever. So I've called the results, the three results A, B, and C. Now compare A and B. 1 plus 3 is 180. 2 plus 3 is also 180. That means since the RHS is equal to the RHS, the LHS will be equal to the LHS. So that means angle 1 plus 3 is equal to 2 plus 3. From A and B. From A and B, we get 1 plus 3 is equal to 2 plus 3. Because the RHS is equal to the RHS. So the LHS will be equal to the LHS. 1 plus 3 is equal to 2 plus 3. So 3 on either side gets cancelled. And we have the result angle 1 is equal to angle 4. Angle 1 is angle POS is equal to angle 2, which is ROQ. ROQ. So we have proved that one pair of vertically opposite angles is equal. Now, in the same way, we'll have to prove that the other pair is also equal. Compare the results B and C. Compare the results B and C. B and C. What do you get? RHS is 180, 180 is equal to 180. So LHS 2 plus 3 is equal to 2 plus 4. 2 plus 3 is equal to 2 plus 4 from B and C. 2 on either side gets cancelled. So we have 3 is equal to 4. So we have 3 is equal to 4. Now you will ask me why you're not comparing A and C. Why not A and C? If you compare A and C, what will you get? You can compare. When you compare A and C, what will you get? 1 minute. Let me first make this clear and then go to that. Yes, children. So from B and C, we get, 2 gets cancelled on both the sides. 2 gets cancelled on both the sides, and we have the result 3 is equal to 4. 3 is SOQ and 4 is POR, and hence we proved that the other pair of vertically opposite angles is also equal. Isn't it simple, children? Please ask me if you have any questions.
No doubts, ma'am.
All right. So this is the proof. Yeah. So the statement which is proved here is when two lines intersect at a point, we know that vertically opposite angles are formed. We know that two pairs of vertically opposite angles are formed. We need to prove that these two pairs of vertically opposite angles are equal. So for that, what we have to do? We have to use a linear pair axiom. We can write 4 results. But it is enough to prove these results. It's enough to write any 3 of the 4 results. Write the 3 results and compare one another. And you will get the required, you will be able to prove the required, fact or the results. Okay. Now I was telling you, when you compare A and B, you get 1 is equal to 2. Now, supposing you compare B and C. B and C. See, you got this result 1 is equal to 2. Now you want to get the result 3 is equal to 4. You want to get the result 3 is equal to 4. Okay, you already got till here. You already got 1 by comparing A and B. You already got this result 1 is equal to 2. Now we want to prove that 3 is equal to 4. Supposing you compare A and C. Supposing you compare A and C. What is A and C? Angle 1 plus angle 3 is equal to angle 2 plus angle 4. Correct, children?
Yes, ma'am.
Okay. All right. Yes. Now, yeah, we need to get that 3 is equal to 4. That means you should cancel out 1 and 2. You should cancel out 1 and 2. Yeah, you can cancel out 1 and 2. No, because 1 is equal to 2. 1 is equal to 2. See, we have proved here 1 is equal to 2. We have proved here 1 is equal to 2. So you can also compare A and C. When you compare A and C, what you will get? 1 plus 3 is equal to 2 plus 4. Now, instead of 1, you can write 2. Instead of 1, you can write 2 because we've already proved that 1 and 2 are equal. So instead of 1, you write 2. 2 plus 3 is equal to 2 plus 4 you will get. 2 plus 4. 2 plus 3 is equal to 2 plus 4. Exactly this result. 2 plus 3 is equal to 2 plus 4. When you compare B and C, that's what you will get. 2 plus 3 is equal to 2 plus 4. So now you can cancel 2 on both the sides and you will get 3 is equal to 4. So when you want to get 1 is equal to 2, no, the remaining 2 things should get cancelled. When you want to prove that 3 is equal to 4, again, the remaining 2 angles should get cancelled. Is it okay, children?
Yes, ma'am. Yes. Yes, ma'am. Yes.
All right, children. Yeah. This we already saw, but I just want to do it again. Let me ask you. Okay, this is NCERT. I have also given you the reference number. Okay, now since I already know this information, children, this is X, children. This is X. See what I've marked. Okay, this is X. It's given in the question. This one is X. Then tell me how much is this?
180 minus x.
180 minus x. Okay, because it's given that this one is x. So the rest of it, because these two angles stand on a straight line POQ. These two angles stand on the straight line POQ. So if the total is 180, one of them is x. The other one will be 180. This full angle will be 180 minus x. 180 minus x. Okay. Now this full angle is bisected by OR. That's given to us. This full angle is bisected by OR. And now this full angle is x. So how much is this one? X by 2. This one also will be x by 2 because the full thing is x. The full thing is x. The full thing is say 100. So each will be 100 by 2, 50, 50. Or if the full thing is 120, each will be 60, 60 because OR is the bisector. So whatever is the angle by 2, this full angle is x. X. So each of the equal angles will be x by 2. On this side also, OT bisects this full angle, this angle. This ray OT bisects this angle. How much is this full angle? 180 minus x. So how much? These two are equal. So each of them will be 180 minus x by 2. 180 minus x by 2. Whatever is that angle divided by 2. Very simple. So this full angle is x. This full angle is 180 minus x. Now this angle is equal to this angle because this is the bisector. OR bisects angle x and OT bisects angle this one 180 minus x. Okay. So x by 2, x by 2. 180 minus x by 2. 180 minus x by 2. Now you have to find ROT. You'll have to find the measure of ROT. What is ROT? ROT is equal to angle ROT is equal to ROS, angle ROS plus angle SOT. See the figure? See the figure? What is ROT made up of? ROT is made up of two angles. ROT, the angle ROT is made up of two angles. It's made up of ROS and SOT. See, this full thing is ROT. ROT is this full angle. It has this angle and this angle in it. ROT is ROS plus SOT. How much is ROS? X by 2. What is how much is SOT? 180 minus x by 2. Now let's work this. So 2 is the common denominator. X plus 180 minus x plus x cancels. 180 by 2 is 90. So the measure of angle ROT is equal to 90 degrees. This is what you'll have to present. This is exactly what you have to present. And you can see it here. That's what we've done first. We first found, we know that, this angle POS and this angle SOQ. POS and SOQ, the sum is 180. But this POS is given to be X. So SOQ will be, that is the rest of the angle SOQ will be 180 minus X. That's what we have found first. Now, after finding this, now you write ROT. This angle ROT is made up of ROS and SOT. What is ROS? ROS, it is half of POS. It's half of this full angle. It's half of POS. And how much is SOT? This SOT, it is half of this full angle, half of SOQ, half of SOQ. See it, children, this ROS is half of POS. This SOT is half of SOQ. See here, ROS, this one is half of POS. That's what is here. And SOT, this one, this SOT is half of SOQ. Half of SOQ. For ROS, we have written this. For SOT, we have written this. You can even write it in the next step below so that you can understand. You can write it here is equal to half POS like this plus half SOQ. That is, for this angle, we are writing this. For this one, we are writing this. Now, how much is POS? POS is X. So half of X. And how much is SOQ? 180 minus X. So half of SOQ is 180 minus X. That's all, children. Then that becomes X by 2 and 180 minus X by 2. Yeah, LCM, and you get ROT is 90 degrees. Okay. This also we saw in one of the last classes. So maybe I'll produce this one. Here the thing is we need to prove that the sum of the four angles formed about O is equal to 360 degrees. We need to prove that the sum of the four angles formed about the point O is 360 degrees or equal to four right angles. 360 degrees is 90 into 4. 360 degrees is 90 into 4. 90 degrees means one right angle. So 360 degrees is four right angles. 180 is two right angles. So we have to prove that the sum of, now in this figure there are four angles. There can be even 8 angles around a point. Not that there should be only 4 angles. There can be 5 angles, 6 angles. In this figure there are only 4 angles about the point O. You need to prove that the sum of these 4 angles is equal to 360 degrees. So for that you will have to make use of linear pair axiom. We'll have to make use of linear pair axiom. So you need to produce and get a straight line. Produce is SO like this. Okay, maybe to a point T. Maybe to a point T. So produce SO to T so that SOT is a straight line. Produce SO to a point T so that SOT is a straight line. Now let's mark the angles. Okay, let's call it 1. Let's call this 2. Let's call this 3. Let's call this 4. Let's call this 5. Okay, and okay, no, before I mark it like this, 1 minute, I should tell you something else. Children, which one is POQ? POQ, POQ. This one is POQ, okay? This full thing, this is POQ. That is 1. POQ is 1, okay? POQ is 1, children. QOR, this one is 2. This one is 2. SOR, this one is 3. SOR is 3. POS, this one is 4. Okay, 4. We need to prove that 1 plus 2 plus 3 plus 4 is equal to 360. But what happens is when we do this, see now you can see 4 fully, meaning 4 is not divided. You can see 3 is also not divided. 2 is also not divided. But this angle 1 is divided into 2 angles. 1 no, because of the construction, because we produce SO to a point T, that angle 1 is divided, not equally. It's divided into 2 angles. So let's call each of those angles 5 and 6. That means 5 and 6 together will make 1. When you understand the proof in numbers, you know, you can write it using angles. You know, angle 4 means angle POS. So when you understand the proof using numbers, when you number the angles and understand the proof like this, you know, it's easy to write whatever you have understood using numbers. The same thing, instead of numbers, you name the angles and write the same proof. That's all. So we'll understand this proof using numbers. I want all of you to understand. So I'm doing it again. Now see here. POQ is this angle. POQ is this angle 1. 1, 2, 3, 4. QOR is 2. SOR is 3. And this POS is 4. We need to prove that this 1 plus 2 plus 3 plus 4 is equal to 360. Produce SO to a point T so that SOT is a straight line. SOT, I think I have done it like that only. Yeah. Okay, so that SOT is a straight line. Now, because of the construction, you can see that this angle 1 is divided into two angles. So let's call each of those angles 5 and 6. Am I clear, children?
Yes.
Yes, ma'am.
Yeah. Now take a line. Oh my God, I should be careful. Now take a line. Which is the line? SOT. Okay. SOT is a straight line. Tell me the ray that stands on SOT. 1 minute. Yeah. So now we'll say ray OP stands on line SOT, correct? Ray OP stands on line SOT. Yes or no?
Yes, ma'am. Yes, ma'am. Yes.
So tell me, yeah. So what will you get using linear pair axiom? The sum of which two angles is 180?
SOP and POT, ma'am.
No, use numbers. Yeah, thank you, but use numbers.
4 and 5, ma'am.
4 and 5,
Yeah.
ma'am.
Yeah, let me write neatly. 1 minute. Ray OP stands on line SOT. So we have angle 4 plus angle 5 is equal to 180 linear pair axiom. Linear pair axiom. Now take another ray on the same line OT. We have only one line here. We have only one line here. So take a ray above it and below it. That's all. Now below SOT, not exactly below, but whatever, to the other side of SOT, we have two rays. You take any one of the two rays. To the other side of SOT, we have two rays. Which are the two rays on the other side of SOT?
OQ and OR, ma'am.
OQ and OR. You take any one. You take any one of the two rays. Which one you want to take?
OQ, ma'am.
OQ. Okay. So ray OQ stands on the same line SOT, because we have only one line here, but we have many rays. We have only one line. So on one side of SOT, there is no problem. There's only one ray OP. On the other side of SOT, we have two rays. We have OQ and OR. Take any one. So we have taken OQ. Okay. OQ stands on SOT. Now, with respect to OQ, you should tell the two angles. You must tell the two angles with respect to OQ. With respect to OQ. So with respect to OQ, we have angle 6 and 2 plus 3 has one angle. Yes or no? With respect to OQ, we have angle QOT and QOS. With respect to OQ, we have angle QOT. See here, QOT and QOS. QOS. This is 180, linear pair axiom. So QOT is nothing. See, with respect to OQ, we have angle 1. On SOT, we have angle 1 and 2 and 3 together. That is QOS. Why I think you're not responding? See here, children, this is the ray SOT. On this, we have one ray like this, OQ. And there's another ray like this, OR. You have taken this ray. So with respect to this ray, there's this angle here and this angle here. With respect to OQ, we have QOT and QOS. Okay, so now QOT is nothing but angle 6 plus QOS. QOS is nothing but 2 and 3. 2 and 3 is equal to 180. Now add these two results. Just write these results and now add these two results. I don't know why I didn't get response here. I'm scared if you didn't understand or I'm not clear. Can I proceed, children, or you have a question?
No doubts, ma'am.
Okay. So with respect to the ray OQ, we have written the two angles. Okay, now add the two results. Just call this result, say A or whatever. This one is B. Now add these two results. Add these results. So A plus B. A plus B gives. A plus B gives what? It gives 4 plus. How do you add? Add the LHS, add the RHS. Add the left hand side. What do you have on the left hand side of both the equations? 4, 5, 6, 2, 3. And on the right hand side, we have 180, 180. So add 360. See here, this one. 4 plus 5 plus 6 plus 2 plus 3 is equal to 180 plus 180, 360. Or you can write 180 plus 180 here. And then you can write plus 360. Okay, is equal to 180 plus 180. Now, see, children, you need to get, or you need to have only angles 1, 2, 3, 4. Now, where is 1? 1 is not there. 2, 3, 4 we have. See, we need to prove 1, 2, 3, 4 is equal to 360. You have 2, 3, 4. You don't have 1. That means 5 and 6 put together is 1. Now, okay, let me arrange it. Let me write 5 and 6 first. Then I'll write 2. Then I'll write 3. Then I'll write 4 is equal to 360. I'm trying to say that we need to prove that 1 plus 2 plus 3 plus 4. That is angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 360. We have angle 2, angle 3 and angle 4. We don't have 1. So 1 should come in the front, right? So I've written 5 and 6 together because we don't want 5 and 6. That should be removed and we should have 1 in place of that. Now what is 5 plus 6? 5 plus 6 is 11. I'm not asking that. What is angle 5 and angle 6 together? Angle 1, right? Angle 1. So 5 and 6 together is angle 1. Plus angle 2 plus angle 3 plus angle 4 is equal to 360. This is the proof. This is what we write by naming the angles. This is only the proof. Maybe all of you can take a picture using your phone or take a screenshot and maybe you can even write it like this. Is it okay, children?
Yes, ma'am.
Yeah. So this is the proof for the sum of all the angles around a point is equal to 360 degrees. That's what is here. That's what is here, but using the names of the angles. You just practice using the numbers. And in the exam, instead of the numbers, you should write the names for the angles. You have to practice, children. See, your tuition notebook is the boundary. You don't have to prepare anything beyond that. Your tuition notebook is the boundary. Practice the same thing many times. That's what we did when we were young. We did not have any external sources for practice. We used to practice only whatever was in our classwork. There was no internet. We were not aware about, reference books, nothing. Even if we went to tuitions, the tuition teacher used to just ask us to work the same thing which is in the classwork. So you must trust that method. So nowadays children feel, I attend tuition, so I know everything in that. I want to work something new. Why should I work the same thing again and again? But I think that is only the tantra for success. It's about you've understood. Your teacher in school teaches you something, and now in this classroom we understand something. So these things which have been explained to you must be practiced. And when you remember these things very clearly, with the help of these ideas, with these inputs, very clear in your mind, you can crack a new sum in your exam. If you ignore your school classwork notebook, ignore the tuition classwork notebook, thinking that, yeah, I understood everything tuition, yeah, I understood everything in school. So what happens is there you're just learning everything once. And remember, our brain is a very powerful organ, but you need to visit the same thing again and again in order to help it retain that information. If you want to retain that information and present it in the exam, you need to revisit, meaning you need to keep practicing that information. You need to keep revising. Then it is registered in your memory. Then your brain is able to retain it. Simply seeing something once, you will understand, but you will not remember that for good. Understanding is different, but remembering what you've understood is a different thing. Remembering what you've understood will happen only if you practice. Now, some subject, even if I don't know that, when somebody explains, yeah, I can understand. If it's put in a very simple language, and if the person tries to teach, maybe I'll understand. But after 5 days, if you ask me about that, I'll not remember. But when the person taught me, I'd have understood. I'd have understood when the person taught me. But I say I don't revise, or I don't see that at all for a few days. How will I remember? I can't. So understanding is different from remembering what you've understood. Now, I believe we understand. Now, when we discuss like this in the class, we understand. But if you don't revise this at all, you just take up the exam like that, thinking that, yeah, I did all this in tuition. You will not be able to remember because you've not practiced. Practice the same thing, children. Practice is very, very important. Without practicing, simply attending, however good the teacher may be, leave my class, whichever teacher, she might be a scholar in her subject, and she may be the best teacher on earth. But the teacher can only teach you clearly. Just because you attend her or his classes doesn't mean that all of you will get full marks. That depends on how much you practice. And practice from your school classwork notebook and the tuition notebook. Don't keep working new things. You cannot remember. You cannot remember. See, all of us we are all normal people, we're not meaning extraordinary. See, if you think you're one of them, maybe working, different things will help you. But I'm telling in general for students, in general, we all need to practice to remember. Just listening to something once, we will not be able to remember it for good. We can't. So maybe some geniuses can do that. Not all of us. Not all of us. So if you feel you're one of those exceptional students, fine. Maybe it'll work for you, but not for all. Please work the same thing. Whatever is in your school classwork notebook, work that. Tuition classwork notebook, work the same thing, because these things you've understood. It's easy. It's interesting to practice the same thing because you've understood it already. So practice will take less time. Do the same thing. That's more than enough. So if you ignore your school classwork and the tuition notebook, and you're doing something from the internet, or you're doing something random, that will not help you. That will not help you. So these proofs you must work again. You must again revise these proofs. Only then you can remember. Please do that, children. Advices, different people will give you different advices. Your friend will say something, another friend will say something else. You do what I'm asking you to do, please. Sorry. Yeah, it's the same thing here, using the names of the angles. All right, children?
Yes, ma'am.
Okay.
Yes, ma'am.
Very nice. Okay, children. Yeah. Now this one, what I told you is when you cross multiply. No, I'm not reading the question because we've already seen it once. You will understand when I explain. This, what I told you is sorry, when you cross multiply, you know, you will get twice ROS. When you cross multiply, you will get twice ROS. So I said, write angle ROS in two different ways and add the two results. You will get this. Express angle ROS in two different ways. So you will get ROS is equal to something. Again, ROS is equal to something else. Don't write the same thing and add. ROS is equal to something. ROS is equal to something else. Now add these two results. You will get twice ROS is equal to something. So then this 2 will come for division and you will get half here. You will get half here. So remember the proof like that. Remember this proof like that. So let us now write ROS in two different ways. Let us now write ROS in two different ways. ROS is angle ROS is equal to, tell me, angle SOQ and what? What should I do?
Minus angle ROQ, ma'am.
Minus angle ROQ. Minus, all of us should understand. See here, I started for you. Angle R. Okay, what is this information? Just what you see. POQ is a line. And then OR you see is perpendicular to POQ. You can see in the figure. OR is perpendicular to POQ. You can see there. And OS is simply another ray. It's not bisecting or anything. OS is simply another ray. OS is simply another ray. OR is perpendicular to PQ. You can see it's marked there. And POQ is a straight line. That's all. You have to prove this result. ROS is equal to whatever there. So angle ROS is equal to, I asked you to complete this, is equal to SOQ. And Madhumita said it right. Minus, all of you see there. SOQ minus, all of you say, SOQ minus what is ROS?
ROQ.
ROQ. ROQ. See your children. See your children. From SOQ, if you subtract ROQ, if you take away this, one, you'll be left with SOR or ROS. See here. Angle ROS, this angle, we have to write this angle. So for writing this angle, I'm taking this whole angle. SOQ minus ROQ, this one, this ROQ minus this one is equal to ROS. That's what you can see here. So further, we know that ROS is equal to SOQ minus ROQ is 90 degrees. Have this result. Now write ROS in another way. Angle ROS is equal to, I'm writing the other side, you know, I'm writing the other side. Angle POR. What? ROS is equal to POR.
Minus POS, ma'am.
Minus POS, minus angle POS. Okay, so see here. See here. We are writing ROS in another way. Okay, so angle ROS is equal to the same angle. ROS is equal to this full angle POR minus POS. This full angle POR minus POS will give you ROS. Okay, if supposing you feel no, this is not easy to understand, let me help you in a different way. Now, I think this all of us will understand. Now, children, tell me what is ROS plus angle ROQ? I think this would be easier to understand. What is ROS plus ROQ, children?
SOQ, ma'am.
SOQ. Now transpose. What is ROS then? ROS is equal to angle SOQ minus ROQ. This is what I was telling earlier. Now we know that ROQ is 90. So SOQ minus 90. This is one, the result one. Now I'm writing angle ROS plus angle SOP is equal to what? ROS plus SOP is equal to what? SOP or POS, whatever, is equal to which angle?
POR, ma'am.
POR is equal to angle POR. So ROS is equal to ROS is equal to angle POR minus SOP, angle SOP. So angle ROS is equal to what is POR? 90 degrees minus angle SOP. SOP. This is 2. This is 2. Now we should add 1 and 2. Adding 1 and 2. Adding 1 and 2. So you will get R. See, this is 1. This one is 1. This one is 2. This is 2. Okay, so you'll get ROS plus ROS is equal to, at the LHS, sorry, RHS, angle SOQ minus 90 plus 90 minus angle SOP. Add the LHS, add the RHS. LHS we have ROS, ROS. So ROS plus ROS. RHS we have 2 things here and 2 things here. Add. So this will get cancelled. So you get twice angle ROS is equal to, you can see that we got the angles which is in the result. Okay, angle SOQ minus angle SOP. So ROS is equal to 2 will come here as half. Half of 2 will come to the other side as half. Half of angle. We have written SOQ, but there it is QOS. Both are the same. You can change it to QOS minus. We have SOP, but there in the result, in the question, it is POS. Both are the same. So is equal to minus angle POS. Prove. Is it okay, children? You need to practice this. See, you might have understood now, but you cannot remember this. For that, you need to practice. To remember, you'll have to practice. Children, please tell me, is it easy to understand?
Yes, ma'am, it's very clear.
Yes, ma'am. Yes, ma'am.
Okay. Because if they ask you, they'll ask you the same proof like this. There'll be no changes with respect to proofs, you know. If at all it comes, it will come in the same way. The same thing will be asked. Maybe they'll use different letters. Instead of POQSR, maybe some other letters will be used to name the points. Otherwise, the same information, same result you'll have to prove. That's the advantage of, you know, proofs. Just have to remember how to do it. Okay. That's what is here, children. Same thing is here. I've written this result directly, that's all. Instead of, I showed you one first step now. I've written this directly. You can write it like this. This is enough. But just in case you don't get it, you can show the step. This one and this one. Please practice. Yeah. This one I'm not doing again because it was clear to you. I think it is simple. We understood the other day. So I'm not doing this. Yeah, now let's do this. So here, children, we have 2 plane mirrors. We have 2 plane mirrors placed parallel to one another. There is a plane mirror PQ and there's another plane mirror RS. These 2 plane mirrors are placed parallel to each other. AB is an incident ray. Okay, AB is an incident ray. So AB strikes the mirror PQ at B. And it is reflected along the path BC, where it strikes the second mirror RS at C and is again reflected along the path CD. You need to prove that this ray, incident ray AB, is parallel to this reflected ray CD. You need to prove that these 2 are parallel to each other. AB is parallel to CD. But I don't know why it's already marked in the figure. It's not, this is maybe, okay, it's this one you don't, like in physics you mark, no, the the direction in which the ray travels, that is marked. Don't mistake this one for parallel lines. For a second, I thought like that. So don't mistake this one to be parallel lines, children. They're showing the direction of the arrow. The ray, direction of the ray. Ray AB, it comes like this and hits the mirror. So that direction is shown here. Don't mistake this for these two are parallel lines. So we'll see the information again. There are two plane mirrors PQ and RS placed parallel to each other. AB is an incident ray. It strikes the mirror PQ at B and is reflected along the path BC, where it hits the second mirror RS at C and is again reflected back along the path CD. We need to prove that this incident ray AB is parallel to this reflected ray CD. And we know the laws of reflection, that the angle of incidence is equal to the angle of reflection. But the angle of incidence and angle of reflection is measured with respect to the normal. Like how we measure angles, like how do we measure angles? Supposing you'll have to, I say, use a protractor and draw an angle of 60 degrees. You need a baseline. You cannot just take your protractor and mark 60 here and from where you just put a line like this. No. If I say, draw an angle of 60 degrees, you'll use a protractor, you'll put a mark here like this 60 degrees. And like this, you cannot just join something like this and say, this is 60 degrees. You need something called the baseline on which you will place your protractor in such a way that the line of the protractor coincides with your line. That is, the baseline of the protractor coincides with the line on your paper. So you need a baseline. Then you will measure, and you will say that this is 60 degrees. So an angle has two arms basically. Similarly here, when we say angle of incidence and angle of reflection, they are measured with respect to the normal. And in physics, you know that normals are perpendicular to the mirror at the point where the ray hits the mirror. Now, these are the 2 points. The ray hits the mirror at B and C. So you'll have to draw normals through these points. So draw normals like this. I'm roughly explaining the proof, then I'll show you the actual proof. So we draw, the ray strikes the first mirror at B. So through B, draw normal. And the ray strikes the second mirror at C. So draw normal through C. Now, what are these normals? These normals are perpendicular to the mirror. These normals, they'll be perpendicular. They'll make right angles with the mirror. Normals make right angles with the mirror. Then which is the angle of incidence? This is the incident ray. This is the normal. This angle is the angle of incidence. The angle between the incident ray and the normal. The angle between the incident ray and the normal is called the angle of incidence. And the angle between the reflected ray and the normal. This is the reflected ray. This is the reflected ray. This is the reflected ray. This is the normal. This is the angle of reflection. Again, with respect to the other mirror RS, this is the normal. For the second mirror, this is the incident ray. For the second mirror RS, this is the incident ray. The angle between the incident ray and the normal is called the angle of incidence. And the angle between the reflected ray, this is the reflected ray. The angle between the reflected ray and the normal is called the angle of reflection. And now we know that by the laws of reflection, we know that angle of incidence is equal to the angle of reflection. By the laws of reflection, we know that the angle of incidence is equal to the angle of reflection. Now you all have to tell me if we have understood so far. So that I can proceed.
Yes, ma'am.
Yes. Understood, ma'am.
Class, use the emoji. Raise your hand. Tanishka, Sindhu, Sanjay, Danya, Madhumita, Raja, Srijana, and Krishmika Shri. Where is Krishmika Shri? Are you there, Krishmika? Raja, you missed a couple of classes in the middle. Did you make use of the recordings? Did you have time to go through them?
Yes, ma'am. I had some time. I finished the recordings. That's why I did not complete the images that you sent. Uh, Sorry, ma'am. Within 1 to 2 days, I'll 1 or 2 days, I'll send everything.
All right, children. So now it's very simple. If you've understood this much, it's very, very simple, the proof. Now, the normals are perpendicular to the mirrors. See here, I'll just show you the mirrors. These are the mirrors. This is one normal, it's perpendicular. This is the other normal, it's perpendicular. Now, these two normals, they are perpendicular to the mirrors. Now they will be parallel to each other. I'll tell you why. These two normals will be parallel to each other. I'll tell you why. Just see here. You don't have to write the proof for all that. You don't have to write the proof for all that. When you just produce a normal like this, okay. Now, if this is 90 degrees, if this is 90 children, this is also 90, right? Because these two mirrors are parallel. These two mirrors are placed parallel to each other. These two are parallel. This is the transversal. Alternate angles are equal. So if this is 90, this is also 90. Parallel line, transversal, parallel line. If this is 90, this is also 90. Because these two mirrors are placed parallel to each other. Alternate angles are equal. Now you can see that co-interior angles are supplementary. 90 plus 90 is 180. Co-interior angles are supplementary. So that means the two normals must be parallel to each other. If these two angles are supplementary, that means these two lines are parallel to each other. So the normals are parallel to each other. The normals will be parallel to each other. I'll tell you again. These are the two parallel mirrors, plane mirrors, which are kept parallel to each other. This is the normal to the first mirror. This is the normal to the second mirror. Where it's 90 only. You can prove that it's they are parallel in many ways. I'm just telling you one of it. Now see here, this is the mirror, parallel, transversal, parallel line. Okay, the mirrors are parallel already. So alternate angles are equal. So you'll get 90 here. Now these are simply, the normals are two lines. The normals are two lines and they are intersected by a transversal such that a pair of co-interior angles are supplementary. 90 plus 90, 180. That means the normals are parallel to each other. Only then co-interior angles will be supplementary. So the normals are parallel to each other. So now this is the normal, this is the normal. They are parallel to each other. The normals are parallel. So see here, parallel line, transversal, parallel line. So alternate angles are equal. This angle is equal to this angle. Supposing this angle 1, this angle 2. Angle 1 is equal to angle 2. Now double it. Twice of angle 1 is equal to twice of angle 2. Now let's call this angle 3 and let's call this angle 4. We know that 1 and 3. Okay. Now how will you write twice of? See, I started like this. 1 is equal to 2 because alternate angles are equal. Then I said twice of angle 1 is equal to twice of angle 2. Now twice of angle 1 means what? Angle 1 plus 1. And what is twice of angle 2? Angle 2 plus 2. Now we know that angle 1 and 3 are equal. 1 and 3 are equal because the angle of incidence is equal to angle of reflection. 1 is equal to 3. So you can write angle 1 like this, and for the other angle 1 you can say angle 3 because 1 and 3 are equal. Similarly here, write angle 2. For the other angle 2 you write angle 4 because we know that 2 is equal to 4. Same reason, angle of incidence is equal to angle of reflection. Now what is 1 plus 3? Angle ABC. Angle ABC. And what is 2 plus 4? Angle BCD. 2 plus 4 is BCD. Now we have a new result. Angle ABC. Angle ABC is equal to BCD. ABC is equal to BCD. Okay, now we have a new result. This angle ABC is equal to BCD. But they're alternate angles made by the transversal BC with the lines AB and CD. And the alternate angles are equal. Therefore, AB should be parallel to CD. These are a pair of alternate interior angles made by the transversal BC with the lines AB and CD. And the alternate angles are equal. Therefore, the lines must be parallel to each other. Hence, AB is parallel to CD. We'll see it again. Normal, normal. perpendicular to the mirror, perpendicular to the mirror. Now the normals are parallel to each other. The normals are parallel to each other. Angle 1, you can mark it angle 2 also, angle 2, angle 3, angle 4. Angle 1 is equal to angle 3 because here parallel line, transversal, parallel line. Angle 1 is equal to angle 3. Alternate interior angles are equal. Twice of angle 1 is equal to twice of angle 3. Angle 1 plus angle 1. Twice of angle 1 means 1 plus 1 is equal to angle 3 plus angle 3. Oh my God, it's already 7:40. Angle 1 plus 1 is equal to 3 plus 3. Now, we know that 1 and 2 are equal angles because angle of incidence is equal to angle of reflection. So angle 1 plus, instead of 1, you say 2 is equal to angle 3 plus another 3, you can make it 4 because they're equal. Now 1 plus 2 is angle ABC and 3 plus 4 is angle BCD. But these are alternate interior angles. Excuse me. But these are alternate interior angles made by the, see, this is ABC, this is BCD. So they are alternate interior angles made by the transversal BC with the lines AB and CD. And they're equal, the alternate angles are equal. So AB is parallel to CD. That's what is here, children. Both perpendicular to the, okay, you would have written it correctly since BA and NC are both perpendicular. The parallel lines. Okay. That's what is explained here, children. Next one. So this is a proof to show that the sum of the three angles of a triangle is equal to 180 degrees. Sum of the three angles of a triangle is equal to 180 degrees. All right. To see the proof. We are about to prove that the sum of the three angles of a triangle is equal to 180 degrees. So supposing we call the triangle ABC. Okay. So we are given a triangle ABC. We need to prove that angle A plus angle B plus angle C is equal to 180 degrees. We have to prove that angle A plus angle B plus angle C is equal to 180 degrees. Start. Okay, we need, sorry. So given triangle ABC, to prove that angle A plus angle B plus angle C is equal to 180 degrees. All right, now supposing we call this angle 1, 2, and 3. Construction is through the vertical angle A. Through A, draw a line. You can call it anything. Let me call it L. Draw L parallel to BC. That is the construction. Construction through A. Draw a line L parallel to the base BC. Through the vertical angle A, draw a line L parallel to the base BC. Now, parallel line, transversal, parallel line, because L is parallel to BC, right? So see here, L, this is L, transversal, this is BC. So parallel line, transversal, parallel line, alternate interior angles are equal. So if I call this 4, angle 2 is equal to angle 4. Alternate interior angles are equal. L is parallel to BC, construction. AB is the transversal. AB is a transversal. So angle 2 is equal to angle 4. Alternate interior angles are equal. In the same way, L parallel line, AC transversal, CB parallel line, transversal, parallel line. Again, alternate interior angles are equal. So angle 3 is equal to angle 5. Now to this result, add 1 on both the sides. Or you can add this. What is this? When you add, you get angle 2 plus angle 3 is equal to angle 4 plus angle 5. Now add 1 to both the sides. Add angle 1 to both the sides. So you'll get angle 1 plus 2 plus 3 is equal to 1 plus 4 plus 5. Add angle 1 to both the sides. What is 1 plus 4 plus 5? 180, because 1, 4 and 5 are 3 angles on the straight line L. 1, 4 and 5 are 3 angles on the same straight line L. So 1 plus 4 plus 5 is equal to 180. This is 180. That means angle 1 plus angle 2 plus angle 3 is equal to 180, because 1 plus 4 plus 5 is 180. So we proved that the sum of the 3 angles of a triangle is equal to 180 degrees. Is it fine, children?
Yes, ma'am.
Yes.
Yes,
Yeah.
ma'am.
Okay. That is what is this proof? Okay. So here, children, let's understand the figure. We have a triangle PQR. This is the original triangle PQR. Okay, which are the two base angles? Okay, let me draw it for you. Okay, we have the triangle PQR. This is the original triangle. Now the side QR is produced to a point S. All right, the side QR is produced to a point S. Now the base angles are this one and this one are the base angles. These two are the base angles. Is it that proof here? Yeah. Oh, it's given like this, is it here? In NCERT, the question will not be given like this. Where did I take this from? Okay, so it'll not be given like this, children. I don't know from where I took this question from. I'll tell you how it will be given. Now, these are the two base angles. This one and this one are the two base angles. Now, this is a base angle, and this is the exterior angle of this base angle. This is the exterior angle of this base angle. This is the interior angle. This is the exterior angle of this base angle. So one of the base angles and the exterior angle of the other base angle, they are bisected. Which are the angles? See, two angles are bisected. Which are the two angles bisected? See, the triangle has two base angles. One base angle and the exterior angle of the other base angle. These two angles are bisected. So this is one base angle. This is bisected. And this is the exterior angle of this base angle. That's also bisected. The bisectors, they meet at T. You have to prove that this angle is equal to half of this angle. You need to prove that the angle between the bisectors is equal to half of the vertical angle of the triangle. It will be given like that only, but if somebody has NCERT with you, can you just read the question from that? Page 108, question number 6. Is it given like this in NCERT?
Yes, ma'am.
Like this, sir, if the bisectors of PQR and PR is?
Yes, ma'am.
Yes, ma'am.
Oh. Okay, so here it's given the see. Sometimes, figure will not be given. That's where we go wrong. Meaning may go wrong or may not be able to. You would have learned that proof, but because the figure will not be given, the information is all given in words. You are expected to draw the diagram and prove it. So you will be caught there. So always learn to draw the diagram. If the information is given clearly about the diagram, Learn to make it, learn to draw the diagram. So I'll explain this to you. Sometimes it will be given like this. This is the original triangle. PQR is the original triangle. Okay. The side QR is produced to a point S. The side QR is produced to a point S. Now the triangle has two base angles. This is one base angle. This is the other base angle. This is the vertical angle. This is the vertical angle of the triangle. This is one base angle. This is the other base angle. This is the exterior angle of this base angle. This is the exterior angle. Now, this base angle is bisected. The exterior angle of the other base angle is also bisected. The bisectors meet at T. You need to prove that the angle between the bisectors, this is the angle between the two bisectors, is equal to half of the vertical angle of the triangle. So one of the base angles is bisected and the exterior angle of the other base angle is bisected. The bisectors meet at T. We need to prove that the angle between the bisectors is equal to half of the vertical angle of the triangle. That's what it is. You need to prove that QTR is equal to half of QPR. What is QTR? The angle between the bisectors. And what is QPR? Vertical angle of the triangle. So you need to prove that QTR is equal to half of QPR. I'll share that question with you later. I'll write and share it with you later. Now, so how we prove this? Now, what you have to do? Now, what you do is we'll use the exterior angle property here. Mostly when the side is produced, when the side is produced, we use the exterior angle property. We use the exterior angle property. Now, see here. PQR is a triangle. PQR is a triangle. And this is the exterior angle. Okay. This is the exterior angle. So what is angle PRS, children? What is angle PRS? What is angle PRS equal to exterior angle property? Yeah.
Ma'am, interior angles of a triangle is equal to the opposite exterior angle. I mean, exterior angle is equal to interior opposite angles.
Sum of the two interior opposite angles. Yeah. So tell me in terms of the angles. Angle PRS is equal to angle
RPQ and PQR.
RPQ. Yeah, or you can say QPR. Okay, QPR plus RQP.
PQR.
PQR plus angle QPR or RPQ, whatever. Okay, fine. This angle plus this angle. Exterior angle is equal to this. That's what we've written here. Exterior angle is equal to sum of the two interior opposite angles. PQR plus QPR. Now divide by 2. Divide this one by 2. Okay, so what will you get? Half of angle PRS. Half of angle PRS is equal to half of angle PQR plus half of angle QPR. All right. Now, what is half of angle PRS? This angle is bisected, no? This angle is bisected. This angle is bisected. So, what is half of PRS? What is half of PRS?
RT, ma'am.
You can write this one or this one, but you write this one. I'll tell you the reason why later. Half of this angle PRS is this or this. You write this one. I'll tell you why later. You write this one. So that means half of PRS is TRS. Angle TRS. Angle TRS is equal to what is half of PQR? Half of PQR. This is PQ. This is also bisected. This is also bisected. So you can write this one or this one. But you write this one. I'll tell you why again later. You write this one. So you can see here. You can write this or this. Here, these two are equal. These two are equal. Now we are writing this angle. This angle PRS is equal to this angle plus this angle. That's what we've written here. When you divide by 2, you will get half of PRS. Half of PRS is this one. TRS is equal to half of PQR. PQR, half of that, write this one. because it's bisected. So TQR is equal to angle TQR plus half of QPR. QPR, you don't know half of it. See, your QPR is this angle. What is half of that? It's not bisected, so you can't write. So write it as it is. Half of angle QPR. Write it as it is. Now this is one result. Have this like this. Now take the other triangle. The other triangle is TQR. The other triangle is TQR. TQR is the other triangle. And you can see that produced and S is here. Okay, the other triangle. See the other triangle TQR. Now TQR is equal to, in triangle TQR, TRS is the exterior angle. TRS is the exterior angle. See, this is over. This is over. Next one. TRS is equal to this angle plus this angle. So you can see here in this figure. We are writing for this exterior angle. This, see this triangle. In this triangle QTR, this is the exterior angle. This one is the exterior angle. And this is, don't see this line. Don't see this line. See only the triangle. Don't see the lines which come in between. Don't see all this. Okay. In triangle QTR, this is the exterior angle. So this is equal to, leave this interior angle. It's equal to this plus this. This angle plus this angle. That's why earlier I said for the two halves, you know, right? This one I said, because now in this triangle also you will get the same angle. And for half of the exterior angle, I said write this one, TRS. See here we wrote TRS because we can write TRS in a different way like this. So now in using the other triangle, TRS, this angle, exterior angle TRS is equal to, this is the interior angle, leave this. Interior opposite angles, this plus this. So TRS is equal to TQR plus QTR plus angle QTR. Again using exterior angle property. See, we have used the exterior angle. There are two triangles, PQR, TQR. See the figure, there are two triangles, PQR and TQR. First, we use the exterior angle property on triangle PQR. And then we divided that equation by by 2 throughout. And we got one result, TRS is equal to something. Now we take the other triangle and the exterior angle is TRS. We write its result using the property. You get TQR plus QTR. Now, TRS is equal to this one. The same TRS is equal to this one. So 1 is equal to 2. TRS, 1 is equal to 2. The LHS is equal to the LHS. So RHS is equal to the RHS. So you'll get angle TQR plus half of angle QPR is equal to angle TQR plus angle QTR plus QTR, equating the RHS. LHS is equal to LHS. So RHS is equal to RHS. Now TQR will get cancelled on both the sides. So you have the result, QTR is equal to half QPR. See here, QTR is equal to half of QPR. Next class, I'll ask you all, we'll revise the same proofs. All of you, please work out so that you can participate in the next class. When we do it again, it will be registered. Now, we are discussing, then you will revise it by yourself. So somewhat 80% will be done. And when we discuss the same in the next class, it should be really clear. So for that to happen, you should have practiced. Okay, that's what is here, children. See here, first exterior angle property we use for one triangle, and we write the result, then we divide by 2 throughout and we get this result. Then we use the other triangle, write the exterior angle property, but A is equal to B, TRS. Yeah, you have the proof in your book. Okay, I think we have to wind up with this one. So this is again a very, very important result, children. This is a very important result. Just have 3-4 minutes, so let me just make it fast. It's a very simple proof also. It's very important and a very simple proof. I'll just explain it and you can go through again at home later. Now, the figure comes like this. How do we get this figure? There is actually a triangle ABC. There's a triangle ABC. Any triangle ABC, it's not equilateral or isosceles or whatever. Triangle ABC. The side AB and AC, they are produced. AB is produced to E and AC is produced to D. So when the sides are produced, exterior angles are formed. Exterior angles are formed. When the sides are produced, exterior angles are formed. This exterior angle is bisected. This exterior angle is bisected. And the bisectors meet at O. And there is an angle formed between the bisectors. You need to prove that this angle is equal to 90 minus half of this angle. You need to prove that this angle is equal to 90 minus half of this angle. That's how you get this figure. Supposing it's described in words. Here they've given you the figure directly. Sometimes the figure will not be given. It will be described in words. You have to draw the figure and then prove. That's what I'm explaining now. Or we have any triangle ABC. ABC, triangle ABC. The side AB is produced to a point E. The side AC is produced to a point D. And so exterior angles are formed. This one and this one, they are the exterior angles. These are the two exterior angles formed. That is BCD is one exterior angle. See BCD is one exterior angle, and CBE is the other exterior angle. CBE is the other exterior angle. Now these two exterior angles are bisected. Bisector, bisector. The bisectors, they meet at O. That means this part is equal to this part, and this part, this angle is equal to this angle. We need to prove that the angle between the bisectors, this is the angle between the two bisectors, is equal to 90 minus half of the vertical angle of the triangle. 90 minus half of the vertical angle of the triangle. This is what you have to prove. To write and explain, it will take time, children. Let me just use the proof and tell you. So first you start writing these results. Okay. Now exterior angle property, you know that this is the exterior angle. Which is the exterior angle? This one is the exterior angle. Okay. This one, this exterior angle is equal to, this exterior angle is equal to, leave the interior angle, leave this one, is equal to this plus this. So 2A is equal to x plus z. 2A is equal to x plus z. So A is equal to x plus z by 2. That's one result. Then again, this is another exterior angle. B, C, D is the other exterior angle. This one, this is the other exterior angle. So 2B, you should mark letters like this, X, Y, Z. You should mark these letters. Wherever I've marked you should mark these letters. Why AA? Because the angle is bisected. So those two parts will be equal, AA. These two parts will be equal because the angle is bisected, BB. So 2B, this angle is 2B, this full angle is 2B, is equal to exterior angle property. 2B is equal to, leave this angle, is equal to x plus y, exterior angle property. 2B is equal to x plus y. So B is equal to x plus y by 2. Now have these two results. Now take up this triangle. Now take up this triangle and use angle sum property. What will you get when you use angle sum property? A plus B plus C is equal to 180. A plus B plus C is equal to 180, angle sum property. But we know A is x plus z by 2. B is x plus y by 2. Substitute. Instead of A, x plus z by 2. Instead of B, x plus y by 2. X plus z by 2, x plus y by 2. Then this plus C is equal to 180. Plus C is equal to 180. Then take the LCM. Take the LCM. See, this is taking LCM. And this is cross multiplying. This is cross multiplying. 180 into 2 is 360. Cross multiply. Now in the numerator, if you see, there is one x, there is one y, there is one z. Gather it. Why to gather? Because x plus y plus z is 180, no? Because they are the three angles of a triangle. X, y, and z are the three interior angles of a triangle. So instead of writing x plus y plus z, you can write 180. Because x plus y plus z is 180. Because x plus y plus z is 180. So instead of x plus y plus z, you can replace 180. Because they are the interior angles of triangle ABC. And we know that their sum is 180. Then this plus x plus 2c, right, as it is equal to 360. So x plus 2c is equal to 360 minus 180. Okay, minus 180. So x plus 2c is equal to 360 minus 180, which is 180. 360 minus 180. This one will come here, 180. Now, what is that result we have to prove, children? What is the result we have to prove? See here. We have to prove that BOC. What is BOC? Angle C is equal to, okay, C is equal to, we have to prove that C is equal to 90 minus half of X. We have to prove that C is equal to 90 minus half X. Okay, so we are almost close. So you should, you now proceed by, proceed with the help of what is to be proved. So you should have C alone on one side. So that's why you're taking X to the other side. See, if C is equal to, you must get. C is on one side, X is on the other side. That's why we are taking X to the, X to the other side. Yeah. See here, children, C on one side, X on the other side. So X plus 2C is equal to 180 after transposing. Okay, now 2C is equal to 180 minus X, 180 minus X. So C is equal to 180 minus X by 2. So see, we have C on one side now. C is equal to 180 minus X by 2. Now there's nothing but 180 by 2 minus X by 2. C is equal to 180 by 2 minus X by 2. Because when it's 180 minus X, see, if you have A plus B minus C by 2, it's nothing but A by 2 plus B by 2 minus C by 2. A plus B minus C by 2 is A by 2 plus B by 2 minus C by 2. So when you take the LCM, what will you get? A plus B minus C by 2. So similarly, this can be written as 180 by 2 minus X by 2. 180 by 2 is 90 minus X by 2. So we got the result. C is equal to 90 minus half C, half X. We got it. See here, we got this. So C means BOC. 90 minus half X by 2 means half X. X by 2 means half X. Half of, what is X? BAC. See there, what is X? BAC. We got it. That's all. So first use exterior angle property and write these results. Get what is A and what is B. Then use angle sum property in this triangle. That's all. First exterior angle property. Then after getting those results for A and B, use angle sum property in this triangle. And then substitute this A and B, what we got, substitute. That's all. Then LCM cross multiply, you'll get the result. One more thing you have to do is after taking the LCM, there is one X, Y and Z, gather that and use 180 instead of X plus Y plus Z, say 180. Because X plus Y plus Z is 180. That's all. Then Y, C on one side, because that's a result. C is equal to 90 minus half X is the result. So you should have C on one side, X on the other side. That's why we are taking X to the other side. After this one, 180 by 2 minus X by 2. 90 minus X by 2. X by 2 means half X. Is it understood, children?
Yes, ma'am.
All right, children. All right, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Thank you.